Hello folks, as I told, we are back with the next video, which is almost like the previous one. Just as I told you, just a converse. I'll just quickly read through the question and then we can go about solving it. Of all the closed cylindrical cans of a given volume, so here the volume, earlier question it was given surface, here given volume, and the volume there it was just given surface. That means we had to assume, but here it's not like that. They give you a number. So given volume of 100 cubic centimeters, find the dimension of the can which has minimum surface area. So you just have to find the dimension. That means you have to find the height and the radius. That's all. They have not put any condition. In the previous question they had also told that h should be and all that. So that work of yours is reduced. So that's about it. So as we go in the previous question, let's have a cylinder whose dimensions, the height is h and radius is r, the volume is v and s is the surface area. Now what's given over here? Given that volume, which we generally call it as v, is 100, which means pi r squared h is 100. We need to substitute. Now generally we always substitute for h, but in certain cases we do substitute for r where things are complicated. Let's go for h here. So h is 100 over pi r squared. Let's call it as 1. And they ask us to find out the surface area. So therefore the surface area S is, we know, 2 pi r squared plus 2 pi r h. So let's quickly go in for that substitution over there, where S is 2 pi r squared plus 2 pi r h. We know that we don't want two variables because we'll not be able to differentiate. So let's quickly go in for the substitution. S is 2 pi r squared remains as it is, and 2 pi r, the h becomes 100 over pi r squared. Why we get it? We get it from 1. After we do that, let's have the pi cancelled r over here. So this is now 2 pi r squared plus 200 over r. So that's our s now fully in terms of r. When s is fully in terms of r, we are ready to take the first derivative. Let's take the first derivative, ds over dr. It's going to be 4 pi r and r raised to minus 1. We'll get the derivative minus 200 over r squared, minus 1 over r squared. You also need to take the second derivative. So that makes it 4 pi minus r raised to minus 2 is going to be minus 2 r cube. So it's going to be minus 400 over r cube. The minus can become plus because another minus would have come. That's it. Once you're done with that, we know that we are ready for the critical point. So let's go for the critical point. Let ds over dr be equal to 0, which means 4 pi r minus 200 over r squared is 0. So when we rearrange, we have 4 pi r squared becoming 200 over r squared. Let the r be on one side. Let the r go there. So r times r squared is r cube. Let the 4 pi come on this side. So we are left with 50 over pi because 4 can cancel. So r can become 50 over pi raised to 1 over 3, that is cube root of 50 over pi, because this was r cube. So this is actually going to be your dimension and this is going to be your answer. R is this. Okay. Now we also have to ensure that there is a minimum. They have told us there will be minimum. So let's ensure that. Therefore, d squared s at dr squared at r, which we have got it as 50 over pi raised to 1 raised to the cube root. Yeah, it's a cube root. So let's check this. This is 4 pi, which says as it is, plus 400 over r cube. So that is yeah, so it's 50 over pi. So maybe 8 pi. So it's coming like 12 pi, which is positive. So therefore, it's mini markers at that point r. So there is a minimum that's happening. Okay, they ask us to tell the dimension. R we have already got. Let's get h. So h, therefore, h is 100 over pi r cube, which means r is 50 over pi raised to cube root and then raised to 2 because it's r squared. So this is going to be 100 over pi, and this is now going to be 50 raised to 2 over 3 and pi raised to 2 over 3. Let's simplify these two. So it's going to be pi raised to 1 minus, let's have this as 50 times 2. So this can be 50, 1 minus 2 over 3, and then 2 of course will be as it is. Then this will remain pi 1 minus 2 over 3. We have simplified the whole thing. So this will be 50 raised to 1 over 3 times 2 times that over pi raised to 1 over 3. Or rather it is 2 times 50 over pi raised to 1 over 3. That's your h. So this is your h value. Maybe how do I conclude? Thus, h is 2 times 50 over pi raised to 1 over 3 and r is 50 over pi raised to 1 over 3 are the dimensions. That's all about this. They have not asked us to prove anything. They have only asked us to show that it is minimum and then find the dimensions, which we have done. We've got the dimensions like this. Technically, if you see h is 2r, h is equal to 2r. They can ask you that show that h is the diameter. We can show that because you have got it there. So that's all about this video. We have done it both ways. When surface area is given, we have found the volume. When volume is given, we have found out the surface area. So this is what happens. With more applications, we meet in the next video. As we always tell, please popularize the channel, let it be known to everybody, and yeah, spread a word. Thank you.